Dear students, very good afternoon. Today we are going to see some problems under limits and continuity. Limits and continuity are very important when we are dealing with differential calculus of several variables. Okay, so when we are dealing with differential calculus of several variables, see, when we are dealing with differential calculus of several variables, limits and continuity plays a important role. Okay, limits and continuity plays a very important role. So let us now discuss some definitions, and after that we shall go for a problem. So first definition is for limits. First definition is for limits. Okay, what do you mean by call limit? Okay, limit means, so in differential equations, when we are modeling some natural problems, we will have some questions among us. Okay, what is the source, what is the destination, and what is the path? Like that, there are some questions will arise. Okay, so to every origin there will be some destination. So to any problem there exists some limit. Okay, so that we should know. Okay, so the limit of a function, I shall dictate a definition and I shall write here. Let f be a function. Let f be a function defined on S. What is S? S is a subset. Okay, that is contained in R2. R2 means it is a real space containing two elements. Okay, that may be x and y. So the function f is said to tend to a finite limit L. Set to tend to a finite limit L. Yes, x comma y tends to a comma b. I hope you are all writing. Let me tell once again. Let f be a function defined on S, that S is a subset contained in R squared, which means subset of R2. The function f is set to tend to means you have to put this limit. F is set to tend to a finite limit L. Yes, x comma y tend to a comma b. Okay, if for every epsilon greater than 0, there exists a delta greater than 0. Such that you will have f of x comma y minus L. On taking the modulus, you will get that finite result epsilon. Okay, for all x comma y also satisfies some condition. Okay, so x comma y satisfying modulus of x comma y minus a comma b less than delta. Okay, so this is, if it is so, then you can write f of x comma y on taking the limit x comma y tends to a comma b will give you a finite limit L, will give you a limit L. Okay, so you should remember this. I shall dictate the definition once again. So what is called limit? If a function is defined on a subset S of, that is a subset of R2, then we can call that function will tend to a finite limit L as x comma y tends to a comma b. The point x tends to a and the point y tends to b. This means that for every epsilon greater than 0 and delta greater than 0. So for every epsilon greater than 0, there exists a delta greater than 0. So this epsilon defines the result of the difference between limit and the function. Okay, this delta defines the difference between the given point and the assumed point. X tends to a and y tends to b. The difference between x and a and y and b, okay, will give the result delta. It should be less than delta. Whereas modulus of f of x comma y, that is a function, and limit L, that is one finite value, will give you the result less than epsilon. Okay, if these two conditions are satisfied, then we can write limit x comma y tends to a comma b, f of x comma y equal to L. Okay, equal to L. So this is the condition for, this is the condition, this is the definition, this is the rule to find the limit, okay, or to say the limit exists or not. If it is not equal to L means limit does not exist. Okay, so then what do you mean by continuity? Continuity is also very simple. If limit x comma y tends to a comma b, f of x comma y equal to f of a comma b means, then we can say f is continuous. Otherwise the f is not continuous. So what do you come to know here? If for the function f of x comma y, okay, if you substitute x to a and y to b, and if there exists a limit L, then automatically f of x comma y will become f of a comma b. So if there exists a limit, the function is continuous. If there exists a limit, the function is continuous. If limit is not existing means the function is not continuous. That is the case here. Okay, you have to understand that. Okay, now we are going to check whether the given function is continuous or not. Okay, so now take down the problem. Now before going into the problem, you have to understand one thing. Here we are taking limit x comma y tends to a comma b, f of x comma y. Okay, so here this limit is called double limit. This limit is called double limit because both x and y are having limits. X is having a different limit and y is having different substitution. X tends to a and y tends to b. Okay, so we have to find the limit after substituting the values for both x and y. Okay, so this is called double limit. Sometimes it is possible to find separately like this: limit x tends to a, and after that limit y tends to b of f of x comma y. Okay, then this may be again equal to limit y tends to b into limit x tends to a, and after that and after that f of x comma y, f of x comma y. Okay, so these kind of things are called repeated limits. Okay, repeated limits means here first we are finding y tends to b, after that we are finding x tends to a. Here we are finding first x tends to a, and after that we are finding y tends to b. So we are repeating the limits for calculating. If the repeated limits exist, mean that double limit will exist. If the repeated limit does not exist, mean the double limit will not exist. Okay, what I am telling now are all important for your exam point of view. Okay, so you have to keep this in mind. So for this case we are going to see one very important example. So after seeing that example, we shall go into the problems of limits and continuity. So our first problem is if f of x comma y equal to x cube, okay, x cube, okay, we shall take it as x square minus y square divided by x square plus y square, where x comma y not equal to 0, x comma y not equal to 0, 0. Find the repeated, question will be find the repeated limits, okay, repeated limits and double limit, comma, if they exist. Dear students, I am once again repeating, here we are first finding the limit by substituting y tends to b. We are not finding a limit, we are substituting the value of y tends to b, after we are substituting value to x tends to a. On the right hand side we are first substituting the value for x, that is a, then we are substituting b for y. So we are repeating the substitutions for both x and y. So these kind of limits are called repeated limits. Okay, so after finding a and b you have to write like that. Okay, here if it exists means you can write it as x comma y tends to a comma b. This is called double limit. Okay, if this repeated limit, if this repeated limit does not exist means then definitely double limit also will not exist. Okay, if it exists means then you can write it as x tends to a bracket, within the bracket you can write y tends to b and write f of x comma y, that is equal y tends to b. For example, if you are getting 1 comma 2 or 0 comma 0 is your values of a comma b means, then you can put a comma b as 0 comma 0 of f of x comma y equal to 0 to 0 of f of x comma y, then that is your repeated limit. Your double limit will be x comma y tends to 0 comma 0 of what is given a question, that you have to write. Okay, f of x comma y may be x square minus y square by x square plus y square. Okay, so now we are going to check that. Okay, so be careful in watching. Okay, be attentive. Always in mathematics the definitions, theorems and the results will be tough to understand. Only by seeing the application, only by seeing the problems, the concept will get clear. Okay, so here solution what is given f of x comma y equal to x square minus y square divided by x square plus y square. Okay, so they have given that x comma y not equal to 0 comma 0. Okay, but for any other value this will come. Okay, when it becomes, that means what is this, what this mean x not equal to 0 means you will get this value. When x and y are not equal to 0 you will get this value. When x and y are equal to 0 means what will you get? Obviously it will become 0. Obviously the given problem will become 0. That is what the given problem mean. Okay, but they didn't mention that. Okay, so now for this you have to take the limit. What you have to take? Repeated limits. Okay, so limit x tends to, we are taking 0 comma 0. Okay, so limit x tends to 0 and y tends to 0 we are taking. Okay, so limit x tends to 0 and after that limit y tends to 0, f of x comma y, this is what we have to find now, equal to limit x tends to 0, limit y tends to 0 of, what is f of x comma y? X square minus y square by x square plus y square, that is equal to limit x tends to 0, then here you have to substitute y for 0. Okay, so you will get you have to substitute 0 for y, so you will get x square minus 0 by x square plus 0, that is equal to limit, I shall write it on the next line, that is equal to limit x tends to 0, x square by x square. Dear students, here all of the sudden you should not apply 0. If you apply 0, it will become 0 by 0, which is indeterminate form. Okay, so don't apply that. It is possible to cancel, so cancel them. Okay, what you will get? 1 times of x square is x square, so it implies limit x tends to 0 of 1. Here there is no x, so there is no need to substitute this x tends to 0. So what you are getting? You are getting 1. This will be your equation 1. Okay, or if possible I shall write separately. Okay, what is your left hand side? Limit x tends to 0, limit y tends to 0 of x square minus y square, x square plus y square equal to 1. This is your equation 1. Now similarly we are finding limit y tends to 0 and limit x tends to 0 f of x comma y, that is equal to limit y tends to 0, then limit x tends to 0. What is our f of x comma y? X square minus y square divided by x square plus y square. Okay, that is equal to limit y tends to 0. You have substitute 0 for x, so 0 minus y square divided by 0 plus y square. Okay, then what you will get? You will get limit y tends to 0 of minus y square by y square. These two will get cancelled and will give you minus 1 as the result, which is limit y tends to 0 of minus 1. There is no need to substitute y as 0 because there is no y, that is equal to minus 1. So what is your right hand side? Limit y tends to 0, limit x tends to 0. You are getting for the function x square minus y square divided by x square plus y square equal to minus 1. This is your equation 2. So equation 1 is giving 1 as the result. Equation 2 is giving minus 1 as the result. So equation 1 is not equal to equation 2. Am I right? Which implies limit x tends to 0, limit y tends to 0 of x square minus y square divided by x square plus y square is not equal to limit y tends to 0, limit x tends to 0, x square minus y square by x square plus y square. X square plus y square. Okay, 1 not equal to 2. Okay, so here these two are not equal, which means therefore repeated limits does not exist, which implies double limit also will not exist. Okay, now we shall move on to finding the. So these are the repeated limits. Repeated limits are not equal. Actually, they are not equal. Okay. Right. The repeated limits are not equal because we are getting the value, but they are not equal. If they are equal, means we can write x equal to 0, y equal to 0. Okay. Actually, they are not existing. They are not equal. Repeated limits are not equal. Okay. You have to write like. They are not equal. Repeated limits are not equal. Okay, sometimes they will not exist also. So okay, if they are not existing, mean also double limit will not exist. Okay, that you have to keep in mind. So if repeated limits are not equal, means also the double limit will not exist. Okay, the repeated limits are existing here, but they are not equal. Okay, say okay. Now we are going for the problem of finding or checking whether given function is continuous or not. Whether given function is continuous or not. Okay. So now take down the problem. Okay, now here is the problem. Second problem. Okay, so test the continuity of the function test the continuity of the function f of x comma y equal to xy divided by root of x square plus y square. Here if x comma y not equal to 0 comma 0, and it will become 0 if x comma y equal to 0 comma 0. So this is the problem they have given. Test the continuity of function f of x comma y at the origin. Okay, so to test its continuity, How we shall proceed? First we shall start with the given function. First we shall start with the given function. So what is given? Given f of x comma y equal to x y divided by root of x square plus y square if x comma y not equal to 0 comma 0 and 0 if x comma y equal to 0 comma 0. In this case we can take limit. Okay, in this case we shall take limit x comma y as like similar to the previous problem. Okay, similar to the previous problem, we can take x comma y tends to 0 comma 0 of f of x comma y equal to here limit x comma y tends to 0 comma 0 of f of x comma y equal to limit x comma y tends to 0 comma 0 of xy divided by root of x square plus y square. Okay, this is our f of x comma y. Am I right? Okay, now dear students, I have already told you that if the given function is continuous means then automatically what condition will hold? Limit x comma y tends to a comma b. Okay, a comma b of f of x comma y equal to f of a comma b. Am I right? So here what they have asked at the origin, continuous at the origin means here a comma b will become 0 comma 0. Limit x comma y, okay, x comma y tends to 0 comma 0 f of x comma y, that is equal to f of 0 comma 0. You should get f of 0 comma 0 if it is continuous. So this is what we are going to prove. Okay, this is what we are going to prove. Okay, so take it down. This is what we are going to prove. So I shall paste here to prove. Okay, since we want to prove the continuity, to test the continuity, we want to verify this. Okay, so to verify what we have to verify, we have to verify this. Okay, we have to verify this. Limit x comma y tends to 0 comma 0 f of x comma y equal to f of 0 comma 0. We have to verify this. If it exists means, if this condition holds good means, then the function is continuous. Okay, okay, now coming to the next step. Our next step is we want to verify this. So how to verify this is very important. Now, okay, now in limits and continuity I have already told epsilon and delta. Okay, I have already told epsilon and delta. So by epsilon and delta definition, by epsilon and delta definition or relation, we are going to prove this. Okay, what is that epsilon, what is that delta? We have already proved x minus a. Then I think I have given in the definition. Okay, x minus a. See above, I have mentioned like this in the definition itself. See here. Yes, here x comma y, see x comma y minus a comma b is less than delta, and limit x comma y tends to a comma b, f of x comma y equal to L when modulus of f of x comma y less than epsilon. Okay, when so you have to keep in mind these three things. Okay, so this is one thing where you can have epsilon, and this is another thing where you can have delta. Okay, also when you are having modulus, for this, you can simply write it as, see here, dear students, see here what is given. I shall copy for your easiness. Okay, what is here? X minus x comma y minus a comma b. Modulus of x comma y minus a comma b is less than delta. Okay, I think I have given one more definition also. So it is also possible to write like this. Okay, if it is like this, means if you are having this, then it is possible to write, the following way. What is that? Square root of, okay, square root of x minus a the whole square plus y minus b the whole square. You can write the modulus in this way also. And this is also less than delta. Okay, so this is also less than delta. Okay, so you have to keep in mind, if it is so, then we can write f of x comma y minus L less than epsilon. Am I right? If these two is possible to write, means then easily what you can say, limit x comma y tends to your a and b. Okay, a comma b of f of x comma y, that is equal to this L. Okay, so this is the way of solving the problem. Okay, so by that we are taking, so now we are going to take the given problem. What we are going to take? Modulus of. Now we are going to take this. Okay, modulus of f of x comma y. What will be our L? Let our L will be 0. Okay, minus 0 equal to what will happen when you are putting like this? Here you will have, see here you have to put limit, no? So you are having modulus of your f of x comma y. What is your x comma y? xy divided by x square plus y square, then minus 0. So this will become modulus of x into modulus of y divided by root of x square plus y square. Okay, so this is there. So what is this value? F of x comma y minus 0, that is less than epsilon. If so, this will also less than epsilon. But you have to know one thing. See, we know that modulus of x is a small value. X is a number, modulus of x is a positive number. Definitely that number will be less than this number. Am I right? So less than square root of x square plus y square. Why we are taking this? Because we are trying to promote this result. We are trying to promote this result. Are you able to understand? We are trying to promote this result here. Okay, here a equal to 0 and b equal to 0 means it will become x square plus y square. Square root of x square plus y square. Automatically we will get delta. Okay, so we are trying to promote that result here. Okay, and also modulus of y less than root of x square plus y square. Root of x square plus y square. Modulus of x is less than root of x square plus y square. Modulus of y is also less than root of x square plus y square. Then what will happen to their product? Therefore, modulus of x into modulus of y will be less than the product of these two. Root of x square plus y square into root of x square plus y square. Am I right? Therefore, modulus of x into modulus of y is less than square root and square root will get cancelled, x square plus y square. Okay, x square plus y square. So modulus of x into modulus of y is less than x square plus y square. Okay, which means here you will have what you will have. So what you will get, this is x square plus y square. Now keep in mind, we know that what you know, x minus 0 the whole square plus y minus 0 the whole square is, okay, square root of this is less than delta, or x minus 0 whole square plus y minus 0 the whole square is less than delta square. Okay, that you have to keep in mind. Okay, now we are going to substitute this result. Now substitute modulus of x into modulus of y less than x square plus y square in which equation? In equation number, we can write this 0 comma 0, this 0 is 0 comma 0, that is our f of 0 comma 0. We are trying to promote a result. Okay, that is right. So this is our equation 1, if it is equation 1. Okay, whether we are having any equations before with number? No, this is your equation 1. So substituting that, what you will get here, f of x comma y minus f of 0 comma 0 equal to x square plus y square divided by, here you are having root of x square plus y square. So it will become, you can cancel these two, you will get square root of x square plus y square. Okay, that is less than epsilon, since you are having less than epsilon. Okay, now dear students, you know that what is the square root of x square plus y square? The square root of x square plus y square is delta. Okay, so here you can see modulus of f of x comma y minus f of 0 comma 0 equal to delta, which is less than epsilon. Okay, which is equal to delta, which is less than epsilon. Now we can take therefore modulus of f of x comma y minus f of 0 comma 0 is less than epsilon. Okay, because we don't know what value is less than epsilon. 0 less than epsilon, we know that. Okay, but we not supposed to get 0 here because we don't know what is f of x comma y's value. Okay, and what is f of 0 comma 0's value. In general we are speaking. So but on substituting we are getting delta. Okay, so f of x comma y minus f of 0 comma 0 is less than epsilon. By definition we know that f of x comma y minus L will be less than epsilon. Am I right? If this definition is true, means what is your L? L is f of 0 comma 0. L is f of 0 comma 0. Am I right? Am I right? Here L is f of 0 comma 0, which implies, so right here L equal to f of 0 comma 0. So by definition what we know? Limit x comma y tends to 0 comma 0, f of x comma y is equal to L if limit exists. Okay, equal to L, that is equal to f of 0 comma 0. Okay, that is what we have written here. Therefore limit x comma y tends to 0 comma 0 of f of x comma y equal to f of 0 comma 0. What is our f of x comma y? Limit x comma y tends to 0 comma 0 of our x comma y is x, I think the question will be xy divided by I think root of x square plus y square. Okay, xy root of x square plus y square, xy root of x square plus y square. Xy divided by root of x square plus y square. Okay, xy equal to what you will get on substituting 0 comma 0, you will get 0. Okay, you should get 0 comma 0, f of that is equal to f of 0 comma 0. Okay, therefore the given function is continuous. The given function is continuous. Okay, therefore the given function f of x comma y equal to xy divided by root of x square plus y square is continuous. Okay, is continuous at origin. Okay, so this what they have asked in the question. Okay, at origin, origin. Okay, so this is the way of proving whether the continuity is existing or not. So for this problem the continuity is existing. Okay, for some problems the continuity will not exist. So in tomorrow class, in tomorrow's video, let us discuss an example problem of what there is the condition or what is the strategy to prove the continuity will not exist. Very simple. One thing you have to keep in mind, if the limit does not exist, means the continuity will not be there. Okay, you have to keep in mind. So that is our main strategy by which we are going to prove the discontinuity, or the given function is not continuous, like that we are going to prove. So for that we will see the problem on tomorrow. Hope you have enjoyed the video. Okay, repeatedly watch this problem, try to understand the concept. If you understand the concept very well, then take down the homework problem. Okay, so depending upon these two problems, I am going to give you two homeworks. Okay, let me give you a problem. Just a minute, I shall search for the problem. Yes, the first problem is, take down, if, okay, this is your homework, if f of x comma y equal to x minus y divided by 2x plus y, then so that limit x tends to 0, limit y tends to 0, f of x comma y is not equal to limit y tends to 0, limit x tends to 0 of x comma y, also so that the function is discontinuous at the origin. Okay, also so that the function is discontinuous at the origin. Okay, this is one problem. Okay, so prove that problem. And by seeing the above problem, you can also prove the second problem. The second problem is examine the continuity of the function. Examine the continuity of the function f of x comma y equal to xy divided by x square plus y square. They have given x comma y not equal to 0 and 0 when x comma y equal to 0 comma 0. Okay, they have given like that. Okay, so you have to prove these two things. Dear students, now let me give you a simple clue for this. Okay, so the above problem is xy divided by root of x square plus y square. Okay, see, the above problem is x divided by root of x square plus y square, but in this problem this root is missing. If this root is missing, means here you will get modulus of x and modulus of y. See, all the steps will be same, but here this will be true Okay, this modulus of x will be less than x square plus y square, modulus of y will be less than x square plus y square, modulus of x into y will become less than x square plus y square the whole square. It will become like the whole square here will come. Here the root will not come, and the modulus of x into modulus of y will be less than delta square. Okay, it will be less than delta square the whole square. That means delta power 4. Delta power 4. Okay. But one thing you will not get on subtracting, you will not get this delta. Okay, this delta. If it is delta means you can say delta less than epsilon. Okay. But if it is delta, I think you may have delta square here on solving. So we cannot say that delta square is less than epsilon. It is not possible to say like that. Okay, it is not possible to say like that. So if it is not, then it will not be less than epsilon. Okay, it will not be less than epsilon. Then definitely f of x comma y minus f of 0 comma 0 will not be less than epsilon, because it is delta square. Okay, delta is less than epsilon. We don't know what about delta square. Okay, yes. So it will become delta square, delta power 4 sometimes. And after that, but actually what should we get? By definition we should get this. Only thing is we should get this. Okay, x square plus y square is less than delta square. Okay, this whole means okay, no problem. If this exists also, we can bring epsilon. Okay, let's try to solve that. Try to solve that. Only by solving only we can say whether it comes delta square or delta power 4, what is coming. Okay, so after that I think whether it is possible or not. Okay, after checking only we can say. So check that. If you get same less than epsilon, okay, check here delta square, delta power 4 or delta. I think delta is not possible, so check that. If it is holding good means then we can say continuous, otherwise it is discontinuous. Okay, okay. And for the first problem, if double limit does not exist, if repeated limits are not equal, the double limit will not exist. If double limit will not exist means what will happen? If the double limit will not exist means then the function will not be continuous. The function will not be continuous. Okay, okay. I hope you can do this problem. So thank you all for watching these two videos. Tomorrow I shall solve these two problems. Okay, thank you all once again.